All right, seniors, welcome back. We got ourselves another beautiful day of home learning here. So as you guys recall from the last lesson, when we did the law of sines, we're kind of getting out of using trigonometry with right triangles, the SOHCAHTOA stuff that we spent a few weeks doing, and now we're using trigonometry with oblique triangles or non-right triangles. So the focus on Tuesday was the law of sines. All right, and the law of sines, we used that when you had a triangle. Let me just draw a little example to remind you. And you were given some angle measure, maybe that was like 53 degrees or something, and you knew a side length, say that was 10. And then you were given another angle measure, maybe that was 30 degrees, and you wanted to find the side across from it. So the key with the law of sines is knowing an angle, a side across from it, angle, side across from it. Okay, that's when you use the law of sines. You'll notice what we're going to do today, you need a different relationship to use what's called the law of cosines. All right, and in just a minute I'll show you what that relationship is, but you essentially have two choices. If you want to find a missing side length, okay, we want to solve for c squared. Here's my little baby c here. What we would need to know first is we would need to know a, which is this side, b, which is this side, so that's just a and b, and then the cosine of c. And remember, this capital C represents this angle here. So what you would need is you would need to know, and if you remember back to advanced, or not advanced geometry, but geometry class you took, that this is side, angle, side. And if you know side, angle, side, then you could find the third side. The other option is that if you knew all three side lengths, you could find one of the angles, and we'll look at that as well. All right, so this is the law of cosines, you guys. You know, if we were in class, I would derive it with you and show you where it comes from, but it's a little bit complicated, so I don't want to waste time or confuse you with that. We'll just do a couple examples instead, okay? And I'll just focus really on what you need to know to be able to use it. All right? So there are two different circumstances when you use the law of cosines. So the law of cosines is c squared equals a squared plus b squared. You'll notice right there, you guys, this is the Pythagorean theorem. Well, the law of cosines is just an extension of the Pythagorean theorem. All right. Oops, forgot my 2. All right. So there, my friends, is the law of cosines. So what we need to have, if we want to find a missing side length, then we have to have side. So we'd have to know this side. Angle, we'd have to know the angle between two given sides. Side, angle, side. So if I knew this angle, and I knew this side, I could then find this missing side. All right, and I'll show you again an example of how we do that. But what we plug in is we plug in the two sides surrounding the angle for A and B, and then the angle we know would go in for C. And if we plugged all that in, we could solve for this little c squared right here. We'll do an example in just a second. The other option is if you know all three sides, then you could solve for this big C here, and that's a little bit more work algebraically, but it's not too bad. So let's just do a couple examples. All right, here we go. So solve for the variables and the triangles below, and so we're trying to find missing side lengths using the law of cosines. All right. So the very first thing is, can you even use the law of cosines? And to do that, remember, you need to know a side, which I know this is 6, another side, which I know this is 8, and the angle between them, which I know is 80. And if I know all of that, then I can figure out what this third side would be. So here's my formula. All right, c squared equals a squared plus b squared minus 2ab times the cosine of c. All right, so what I'm going to plug in for is the side, angle, side stuff goes on this right side for A and B, and then the big angle C. And the little x that I'm solving for, that's going to be my C right here. So here I go. So this is going to be like A, B, big C, little c. So I do not know little c, that's x. I know A is 6. That side is 6. I know that B is 8. 2. A is still 6. B is still 8. And then the cosine, and the angle here, this big C, is 80 degrees. All right, so I've plugged it in. It doesn't matter which one of these sides that are next to the angle you call A or B. That doesn't matter. So I called A 6 and I called 8B, right? It doesn't matter as long as the side across from the angle is what you plug in for C and what you're solving for. So now just a little bit of algebra. Here we go. So I know that x squared is equal to, you guys, all I'm going to do is just plug this entire thing into my calculator. Let me get my calculator out. All right, I got my calculator out here, and, well, it just disappeared. One thing, you guys, remember, always confirm it's in the right mode. So if I hit the mode button, I can see right now I'm not in degree mode. Got to be in degree mode. And remember, the way I told you to test that is the sine of 30 should always be 0.5 if you're in the right mode. So I'm good. So look, all I'm going to do is just punch all of this in the way I see it. So 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 80 degrees. Bam. So I get x squared is 83.3298 or whatever. All right, so let's just call it 83.33 for now. But that's x squared. So what I need to do next is just take the square root of both sides. So I'm just going to go back to my calculator. I'm going to hit second square root, and my little square root option is here. But then instead of just typing this in again, you guys remember I could always do second, this little option down here, answer. It'll square root that previous answer. So I'm going to square root it, and then I get the x is about 9.1. So this might be a good time for you to pause the video and try it on your own, see if you can get the same answer. All right, but I'll go ahead and start doing it if you want to just follow along again. So again, in order to use this to find a missing side length, so this is the side I want to find right here, I have to know the side angle side stuff across from it, which I do. I know this is 9, I know this is 5, and I know the angle between is 47. So I'm just going to plug in c squared, a squared, plus b squared, minus 2ab, times the cosine of c. So again, the part over here all by itself is my c. I call either one of these a or b, it doesn't matter. And this is my big C, or the angle, 47 degrees. So I got w squared is equal to 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 47 degrees. So again, I'm just going to go ahead and I'm going to punch all of this into my calculator. Get the calculator out of the way here. And here we go. So 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 47. Just punch it all in exactly how you see it. You get w squared is 44.62 roughly. But I don't want w squared, I want w, so I'll square root both sides. So I'm just going to hit square root, and then this little answer button down here, the previous answer. Square root of 44.62 is like 6.67, so about 6.7 we'll call it. So w is about 6.7. So you guys, that's how you use law of cosines to find a missing side length. All right? And remember, in order to do that, you have to know an angle and then the two sides surrounding it, and then you can find the side opposite that. I got to know an angle, the two sides around it, and I could find the side opposite that. The other application of the law of cosines is you can use it to find a missing angle. Now this, you guys, tends to be a little bit more of a pain in the butt, so just kind of bear with me and pay attention. So here is my side angle side situation. All right, and this is the guy across from it. That's going to represent C. All right, so my A, my B, and my big C are the parts that make up the side angle side over here, and then the little c that goes by itself is the side across all by itself. So let's plug into the formula. You get c squared equals a squared plus b squared minus 2ab times the cosine of c. All right, so I'm just going to plug in 7 for c, because this is the side all by itself, not part of the side angle side stuff over here. So 7 squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times the cosine of theta. Now, this is the tricky part. Remember, just like with all the other trick stuff we've done, if we want to solve for an angle, eventually we're going to use that little second cosine option, the inverse cosine option. But before I can do that, my goal is to get this part all by itself. So pay close attention to how you simplify this. This is a common source of error. All right, so 7 squared is obviously 49. 8 squared is 64. 6 squared is 36. Minus 2 times 8 times 6 is 96 times cosine of theta. And again, my objective is to get this part all by itself so I can do the inverse cosine. So now I'm just going to tighten this up a little bit more. 49 equals 64 and 36 is 100 minus 96 cosine theta. Now right here is where the most common mistake happens. You cannot subtract 100 minus 96 because this 96 is being multiplied by the cosine of theta. So you have to divide this away. So here is where things get tricky. What we're going to do next is we're going to subtract 100 from both sides. So you get negative 51 equals negative 96 times the cosine of theta. So now I'm going to divide both sides by negative 96. All right. And when you divide a negative by negative, we know you get a positive, so I'm just going to disregard the negative symbols. So I get the cosine of theta is equal to 51 over 96. So now, to solve for an angle, I'm just going to punch that in my calculator like this. So here we go. Pull out the old calculator, and I get second cosine, and then inside of that parenthesis, I'm just going to put that fraction. Second cosine 51 over 96 gives me around 58 degrees. So theta is approximately 58 degrees. All right, let's just do one more of those. Make sure everyone's on the same page, all right? And I want you to pay close attention to how I simplify this. All right, so first thing, where's my side angle side crap? All right, so here's my side angle side. So that's going to be A and B and big C. And then this little guy all by my little self over here, it's my little baby c. So I got c squared equals a squared plus b squared minus 2ab times the cosine of c. So for c I have 10 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of theta. So 10 squared is 100. And 6 squared is 36. 8 squared is 64. Minus 2 times 6 times 8 is like the same numbers I just used. Not very creative. Is negative 96 cosine theta. So I just did this. It's 96. Alright, so now I get 100 equals 36 and 64 is 100 minus 96 cosine of theta. Now remember, the objective here when you solve for an angle is to get the cosine stuff all by itself. So I'm not going to subtract 100 minus 96. All right? Rather, I'm going to subtract both sides by 100. And I'm sorry I used the same numbers again. Again, I wasn't being very creative. So then I get 0 on the left equals negative 96 times the cosine of theta. Then I'll divide both sides by negative 96. Because again, my objective is to get this part all by itself. Scroll down a little bit here. All right, and when I divide both sides, I get that 0 divided by negative 96 is equal to cosine of theta. So, to solve for an angle, I'm going to punch that in my calculator like this. So second cosine, and then I put that fraction 0 divided by negative 96, and you guys know that is just 0. So inverse cosine of 0 is 90 degrees. Theta is equal to 90 degrees. There you go. Now, you guys, just like the last problem the other day, look, if you remember your Pythagorean triples, 6, 8, 10 is a right triangle. That's why that's 90 degrees.